So the first of a few videos on the heart. This is chapter 18 from your Myriad book. Okay, so the heart is found in the middle of your chest, right behind your sternum, in an area called the mediastinum. It's the area between the two lungs. Excuse me. It's about the size of your fist, so it's not as large an organ as most people think. It rests on the superior side of the diaphragm. It really is on the midline, and then the apex veers to the left, so it's really kind of to the left. About 2/3 of it's to the left. It takes up almost the entire space between the thoracic spine and the sternum. It's surrounded by a bag, like it's found in a bag, like a lot of organs. Now, that's called the pericardium, which means around the heart. The pericardium is a double-walled sac. It has a dense connective tissue sac that protects the heart and anchors it and prevents it from overfilling. As blood fills the heart expands, but the fibrous pericardium doesn't, so it creates the upper limit on filling. It's like I say, it's connective tissue, so it is primarily collagen fibers. Deep to the fibrous pericardium is the serous pericardium. Now, the serous pericardium has two layers. There's the layer that's around lining the fibrous pericardium is called the parietal layer, and the layer that's actually on the surface of the heart is called the visceral layer of the serous pericardium. The visceral layer of the serous pericardium is actually the most superficial layer of the heart wall itself, so it gets the name the epicardium. This is a recurring theme. We're going to see this a lot in all the organ systems, everything that's located in the thoracic and abdominal cavities. There is a serous membrane that lines the cavity and coats the organ, and the space between them is filled with fluid, which is really just for lubrication, protection, nourishment, that kind of thing. So the layer that's lining the cavity is always called the parietal layer. The layer on the organ is always called the visceral layer. So around the lungs, we're going to have the parietal pleura attached to the backside of the ribs, and the visceral pleura, which is attached to the lungs. When we talk about the intestines, there's the parietal peritoneum and there's the visceral peritoneum. When we talk about the ovaries, there's a parietal and a visceral layer as well, etc. Like it is a very common designation that just gets repeated. Parietal lining the cavity, visceral on the organ, on the viscera. If we go back to here, this is where we find it. As you can see, it's mostly to the left. The point of maximal intensity is actually where the apex kind of touches the ribs. The base is closer to the spine, and so you can palpate the heart beating actually at that point of maximal intensity. This is what the mediastinum and the pericardium looks like. So you'll see that the lungs with its pleura, visceral and parietal pleura, the hook is between the two and the pleural space. This is the fibrous pericardium that's been cut. You can see that it's attached to the blood vessels here. And the serous pericardium is lining that. The parietal part is here. The visceral part is on the heart itself. The space between them is the pericardial space. In cross section, we can see here right where the pericardium anchors. It's this fibrous pericardium, and this happens to be anchored to the pulmonary trunk here. The parietal layer of the serous pericardium, the visceral layer of the serous pericardium, also called the epicardium. This is heart muscle, so that's the myocardium. This layer here is the endocardium, and this is the space where we find the blood, the chamber of the heart. In this case, it happens to be the left atrium. So, the epicardium, it's a serous membrane. I've said that, it seems already too many times, but that's what it is. The myocardium is made of primarily cardiac muscle cells. There is a fibrous skeleton. There are collagen fibers because muscles need something to pull on, and so it's almost like an internal connective tissue structure that the cardiac muscles pull on. It gives the heart its shape. It creates support, and because it is connective tissue, it is mostly extracellular fibers, so it can act as insulation and limits the spread of action potentials. The endocardium is epithelial tissue. It lines all the chambers, and it's continuous with the endothelium that lines all the blood vessels. And it basically makes the chambers waterproof, makes them so that they don't leak. It has some physiological properties that inhibits clotting and a few things like that. But primarily it is just a lining. So there are basically the four layers. There's the pericardium, which is the fibrous pericardium, the parietal layer of the serous pericardium. There's the pericardial space. There's the epicardium, which is epi means on, so it's on the heart. There's the myocardium. Myo means muscle, so it's the muscle of the heart. Endocardium lines the chambers of the heart. Endo means inside. Once you know what the words mean, it is obvious what these things are. Excuse me, I'm going to... So, if, for instance, on a test we were to ask a question like the layer of the heart wall that is made of cardiac muscle is the A, pericardium, B, epicardium, C, myocardium, D, endocardium, it's going to be myo. Myo means muscle. The layer that lines the heart, the epithelial layer that lines the heart, will be D, endocardium, things like that. There's this same picture again, just to reiterate. Now, the fibrous skeleton and the direction of fibers of the cardiac muscle bundles look like this. It's kind of got this, almost this Mobius strip look to it. You'll notice that the two atria at the top are kind of circular. They surround the organ, and that the bundles that in the ventricles have this twist. So not only will it contract and push the blood like air in a blood pressure cuff pump, but it also twists. So it almost wrings blood out of the ventricles at the same time. You can see how if those things tighten, that the whole heart will twist like wringing out a cloth. Makes it more efficient. It moves more blood with a given amount of force. There are 4 chambers within the heart. The receiving chambers are called the atria. In a building, the receiving chamber inside the front doors is the atrium. You walk into the Paul Sadlin building, the M building on campus, that area right in front of where the waiting rooms for the clinics are is the atrium of the building. You walk into any office building, there's an atrium. Atrium means receiving chamber. There are 2 of them. There's the right atrium and the left atrium. And in between the 2 is a wall of muscle called the interatrial septum. Septum literally means a wall of tissue. You have a nasal septum. If you want, palpate it. On the outside of the heart, you can tell where the atria ends and the ventricles begin by a groove that circles the heart at the bottom part of the atria. This is called the atrioventricular groove, or the coronary sulcus. The coronary sulcus is the more common thing. Now, there are appendages on each atria that stick out like ears, so they're called auricles, and they just provide more space for the blood. They're just appendages that increase the volume of the atria. There are 2 ventricles, and the ventricles are the big muscular parts of the heart that do the pumping. There are a left and a right ventricle. In between is a very robust muscular wall called the interventricular septum. Again, on the surface, you can see little grooves, shallow grooves, that demarcate the left and right ventricle. They're called the anterior and posterior interventricular sulci. They're located right over the interventricular septum. And major blood vessels, the coronary vessels, run in these grooves. So when we look at this, these are the auricles of the right atrium and the left atrium. Now, something that I should note at this point is that we always talk about the heart's left and the heart's right. So the dead guy's right. So when you're looking at the picture, the right atrium is on the left side of the page when you're looking at this view. Always keep that in mind. People get that backwards all the time. This is the coronary sulcus here, running along there. It's where the coronary artery, the right coronary artery, runs. The left coronary artery is here in the sulcus on the left. This space here is the anterior interventricular sulcus with the anterior interventricular artery and anterior interventricular vein. The point of the heart is called the apex. This part up here where the great vessels are is called the base. Now there are 4 main great vessels. Blue indicates that there is no oxygen. It doesn't indicate whether it's an artery. This, in fact, is an artery. This is the pulmonary artery, the left one and the right one here, where they join, or where they branch from the pulmonary trunk, which is really the main pulmonary artery. That comes out of the right ventricle. It carries deoxygenated blood. This is the aorta. It's the main systemic artery of the body. It comes out of the left ventricle and it carries oxygenated blood. Coming back from the body is the superior and inferior vena cava. The superior vena cava collects blood from everywhere above the diaphragm and brings it back to the right atrium. The inferior vena cava collects blood, all the blood from everywhere below the diaphragm, and brings it back to the right atrium. The pulmonary trunk and the pulmonary arteries take deoxygenated blood to the lungs, where it drops off carbon dioxide and picks up oxygen, so it becomes oxygenated again, and it comes back from the lungs through the pulmonary veins, and you notice they're red. So on the pulmonary side, veins carry oxygenated blood. Here and here. There's 4 of them, and 2 from the left and 2 from the right. And they enter into the left atrium. Blood then flows from that to the left ventricle, out the aorta to the body, through the capillaries of the body, back through the vena cava, into the right atrium, into the right ventricle, out the pulmonary trunk and the pulmonary arteries to the lungs, and it's a circuit that way. I'm not expecting you at this point to, in this lecture, to be able to name these, but there's the brachiocephalic trunk. The way that the name works is brachio means arm, cephal means head, and trunk means an artery that's going to multiple places. So the pulmonary trunk goes to both lungs. The brachiocephalic trunk goes to the head and the arm on the right side. Because this is already to the left, we don't need a trunk to go to the left side. So the common carotid goes to the head on the left, and the left subclavian goes to the arm on the left. So that's why there's 3 here. This brachiocephalic trunk will branch into the right common carotid and the right subclavian, right about here, just on the other side of the midline. That's about it for this diagram. So when we look at the atria, the walls aren't that thick, but they have muscles that look like they're combed out. The walls are not smooth. They have ridges, and the ridges in it are called pectinate, and pectinate means combed. It's got these parallel ridges. And what this does is allows more muscle mass for contracting without using up too much of the chamber volume for holding blood. So in the right atrium, there are 3 ways that blood come into it. Like I said, everything from above the diaphragm goes to the superior vena cava, so blood from your head, from your arms, from your thorax, from all around your ribs, all of that goes into the superior vena cava. All the blood from below the diaphragm, from your legs, from your abdomen, all of that ends up going into the, or for the most part, there is a minor exception, goes into the inferior vena cava. These are 2 very large blood vessels, very low pressure, very large blood vessels that bring the majority of the blood back to the heart. Now, the heart itself has a circulatory system called the coronary. Blood leaves the aorta, feeds the walls of the heart, the muscles of the walls of the heart, and then it's collected up by the coronary veins, and then it returns to the vena cava through an opening called the coronary sinus. It doesn't bother going back to the vena cava because it's already there. So there's an opening called the coronary sinus. And yeah, that's a good landmark. We'll see this again. On the left atrium we're receiving blood from the lungs. So these are the right and left pulmonary veins. This is oxygenated blood, even though it's veins. The ventricles push the blood out to either to the lungs, in the case of the right ventricle, or to the rest of the body, in the case of the left ventricle. Inside the chamber, there's all kinds of these muscular ridges, and some of them are even not, they don't even seem to be attached. They're called the trabecula carne, which really means walls of meat. And their job is to increase the muscle mass, to increase the contractility and the strength of the heart, again, without taking up too much room in the chamber that needs to hold blood. So it doesn't decrease the volume significantly, but it increases the contractility greatly. And in the trabecula carne, there are some specialized little nipples of muscle called the papillary muscles. They're on the right side, there are 3 of them. On the left side, there are 2 of them. The great vessels that leave the ventricles is the pulmonary trunk on the right side and the aorta on the left side. They are both arteries because they take blood away from the heart. Veins always take blood towards the heart. arteries take blood away from the heart. So when we look inside the heart, we're seeing here in the right atrium, superior vena cava, inferior vena cava, and right about here, it's not even shown, is where we're going to have the coronary sinus. This space here is called the fossa ovale. Now, in the fetal heart, blood doesn't go to the lungs because the baby is not breathing. The blood gets oxygenated at the placenta. So blood flows actually through this hole in the septum, right across to the left atrium, and circulates here. The right ventricle doesn't do very much prenatally. And so there is an opening right here. It's called the foramen ovalis. When the baby is born and takes its first breath, the flap that is on the foramen ovalis ends up fusing, and it's left with this, almost this scar called the fossa ovale. When we look at the inside of the atrium, we see the pectinate muscles here. These things here in the ventricles, all of this, is the trabecular carne. These are the papillary muscles, 2 on the left, 3 on the right. This is the interventricular septum here. The pulmonary trunk is here with its valve. The aorta comes right down here, and so it exits the ventricle right there at the aortic valve. Excuse me. Excuse me. These valves are between the atria and the ventricle. There's one on each side. They are called the atrioventricular valves. So there are 4 valves in total. 2 on the right side, 2 on the left. The ones that go to the great vessels, to the pulmonary trunk and the aorta, are called semilunar valves because they look like half moons. These valves here are called the tricuspid and the bicuspid valve. This has 3 cusps, you can tell by 3 papillary muscles, so 3 flaps of this. This one has 2. On the right side, the name you'll hear most often used is the mitral valve. We'll talk about these momentarily, but we have mitral valve, aortic semilunar, pulmonary semilunar, and bicuspid. I always remember this from when I was a student. With the mnemonic, you try to be right. Tricuspid on the right. And then for the mitral becomes the left. I think I'll end this video here, and we'll pick up at pathway of blood in the next video.